Hello everyone, let's get right down to business. For number one, we have the question. The diagram below shows two half-meter rules that are marked off at 5 cm intervals, and identical metal discs are placed on the rules as shown. Now, because they're identical metal discs, you didn't have to give them a value. You could have worked with X, but for those who are comfortable giving them a value, 2 newtons, 3 newtons, 1 newton, and working with that, that will work for now. Alright, so I'm using Miss Ali's paper. Alright, the only problem with this answer is at the beginning of the question, it is stated that clockwise moments is equal to anti-clockwise moments here. And that's only the case when the system is in equilibrium. Now, because it is not in equilibrium, at the end you end up saying 40 is equal to 30, which is not correct. Right? So, what we should do is just state the clockwise moments. State the clockwise moments. Clockwise force times distance. So I used X newtons as a force. Clockwise moments, and then you do anti-clockwise moments, and then you state that since the anti-clockwise moments is greater than the clockwise moments, then the system will turn anti-clockwise. Alright, next question. For B, we sum the clockwise moments. Force times distance is equal to force times distance plus force times distance anti-clockwise. This is equal to force times distance in the clockwise moment, and we have the same answer. Therefore, the system is in equilibrium. This is an example or a question where the person worked it out, assumed the force was equal to 2 newtons. I usually use X, but it would not matter. Alright, number 2. Oh, 1 second. Alright, number 2, we have a rule. It says if the rule is balanced, what are the respective values of X and Y? So, yes, because the rule is balanced, the first thing that was stated is that the total clockwise moment is equal to the total anti-clockwise moments, which is correct. Alright, therefore 20y is equal to 12x. Alright, now with 20y is equal to 12x, whenever you work it out, you can do a substitution right there, and what you would end up with is this. This is what you did. At 20y newton meters is equal to 12x newton meters. What you could do is do a ratio, divide both sides by 12 and both sides by y, and you see 5 divided by 3 newton meters is equal to x over y newton meters. Therefore, the x to y ratio must be 5 to 3, and that was the B part of the question. We did it along the way by substituting each of the answers, but you still got it in the end. But this is you won't do something like that in a test. Alright, next question. Alright, number 3. In the diagram above, the distance AC is equal to CB. Calculate in both cases the force X, which is keeping the system stationary. Alright, so I actually did not answer this question, but The correct answer to the question, so we simply say is that the force anti-clockwise is equal to the force clockwise. Similarly, total force in any direction is equal to the force in the opposite direction. So for the first part of the question, which is this one here, we don't have any clockwise or anti-clockwise moment, because the point at C is not a fulcrum. It's just saying that the force is acting upwards from at that position. Right, so just say total force up is equal to total force down. So total force up is 10 plus 10 newtons, which is simply equal to 20 centimeters. For the other questions, right, there's just the clockwise moment is equal to anti-clockwise moment. So total force down is equal to up one direction and the other direction. So the force bar x is just equal to 10 plus 10, 20. Yes, the second one, anti-clockwise moments is equal to clockwise moments. So we sum the anti-clockwise moments, which is 10 newtons multiplied by y meters. I put y meters because they did not give any distance. They just said that AC is equal to CB. Because I'm trying to find for x newtons as the answer, I can't put my distance as being x also. I have to choose a different variable. So I call the distance y. So AC is y and CB was also y. So from A to B would have been 2y. So AC multiplied by AC is the distance that a clockwise moment is acting at, the distance from the fulcrum. So the clockwise moment is 10 newtons at point C times y meters, and the anti-clockwise moment is x newtons times 2y meters. And working that out, we see that x is equal to 5. And that is the question. Alright.